Hello friends, our topic is law of radioactive decay. So in this law, actually this law starts from one equation, and that is delta n by delta t, which is proportional to n. Now what is delta n? Delta n is the number of nuclei which is decaying, n is the number of nuclei, right? And delta t, that is the time interval up to which time this delta n is decaying from the previous nucleus, right? So delta n by delta t. Now in this formula we can write dn by dt, because n is the differential with respect to time. So we can write dn by dt proportional to, but if I remove here proportionality sign, then there will be is equal to and negative sign. So why negative sign comes to this equation? Because this nuclei, this number of nuclei, because of decaying of nuclei, it will be reduced. So because of decreasing manner, we have to write here negative sign. So negative lambda, lambda is our radioactivity constant, right? So now dn, we can write n here is equal to minus lambda dt. Now in this equation we can integrate, so integration dn by n is equal to minus lambda constant integration dt. So this integration here, it is from 0 to t, and this integration from n0 to n. So what is n0? It is our initial number of nuclei before any decay, and n after t time number of nuclei which is now it is remaining, right, inside the nucleus. Okay, now integration dn by n, it will be ln n. Now upper limit n, lower limit n0 is equal to minus lambda. Here because of this term integration, t minus 0 will be there. Now upper limit minus lower limit, so ln n minus ln n0 is equal to minus lambda t, right? So ln n minus ln 0 is equal to minus lambda t. Now I can write ln here, because of subtraction we can write in division ln n upon n0 is equal to minus lambda t. Now if I remove ln from here, n upon n0 is equal to e raised to minus lambda t. So our last equation will be n is equal to n0 e raised to minus lambda t, right? So this is the number of nucleus, this is the number of nucleus initially, and this number of nucleus are of at t time. So this equation we can find number of nuclei which is remaining inside the atom, right? Now here we comes to another equation which is r is equal to, we know that it is minus dn by dt. So if r is equal to minus dn by dt, I can write r is equal to, now put this formula here, it is lambda n. Okay, now put n equation here, what happens? R is equal to lambda n0 e raised to minus lambda t, and here r is equal to, r is called radioactivity. Here r is called radioactivity, this is activity. Okay, so this is our r equation. Now in this equation r is equal to lambda n0, we can write r0 e raised to minus lambda t. So we can write r0 is nothing but lambda into n0, right? Now we want to find half-life of any atom, of any element of radioactive. So half-life, to find that, see, our n now becomes n0 by 2. Whenever it comes to half number of previous nuclei numbers, so we can write this formula here. So ln, see, if I want to give negative sign to here, what happens? Ln n0 upon n is equal to lambda t, right? Now ln n0 upon here, it is n0 by 2 is equal to lambda t. So we get ln2 is equal to lambda t. So ln2 is equal to lambda t. Now I have to write here, it is for half life, that's why I have to change the sign of t, and it will be now tau 1 by 2. So tau 1 by 2 is equal to ln2 upon lambda and Ln2 value is 0.693 upon lambda. So that is the half-life of our elements. So this is our equation, right? Ln2 is equal to lambda tau 1 by 2 and tau 1 by 2 constant, and then we have Ln2 by lambda. Ln2 value is 0.693. So this equation is known as half-life of our radioactive element. Now average life of a radioactive element. So after so many differentiation and integration, it comes to this equation that tau is equal to 1 upon lambda. So this equation is from average life, right? So it is average life of our radioactive element.